That one. Daniel, yes.
So, wait.
I can go back to my whiteboard if I need to.
That's okay. Oh yeah, could we also write, because I know in the book it's like negative sign of t instead of sign of t minus pi?
Yep, yeah.
Because it like flips it.
Yep, because
But
if you shift a sign function by pi, that means you've basically flipped it horizontally, so that's a negative. Yes, you can do it that way if you want to. And this is a drawback of the book. They do simplify their stuff way more than I expect you to, so sometimes your answers don't look the same as what they do in the back of the book. But yes, you can write it that way also. Yes.
Okay, thanks.
Okay, other questions. This is a good one because we're putting together a bunch of stuff. Other questions? Anything else? Okay, then I got one more example that puts together even more stuff. Here we go, let's try this one. I think that tomorrow I'm gonna have you probably in breakout rooms a little bit more, but today I just wanna do some examples because there's a lot of stuff going on here. All right, here's my last one. For example, x double prime plus 2x prime plus x equals delta of t minus delta sub 2 of t, and x naught is 2, x naught prime is also 2. X double prime plus 2x prime plus x equals delta of t minus delta sub 2 of t. X naught is 2 and x naught prime is 2. Initial position is 2 units stretched. Initial velocity is 2 units to the right. I'm giving the object a shove at time t equals 0, and then I'm giving the object a shove in the opposite direction at time t equals 2. I've got a negative, so a shove in the opposite direction at time t equals 2. Laplace transform, here we go. S squared, capital X of s, minus 2s minus 2, plus 2 times s capital X of s minus 2 plus capital X of s equals e to the negative 0 times s minus e to the negative 2 times s. You can write e to the negative 0 s as just 1 right away if you want to. I'm going to skip the algebra step and get you to capital X of s equals 7 plus 2s minus e to the negative 2s over s plus 1 quantity squared. The written out algebra is in my notes. You can write out the algebra. Stuff comes over to the other side of the equation, and you can see where the 7 comes from, where the 2s comes from, etc. Okay, so I'm skipping the algebra steps. They're in my notes. Okay. We've got 2 things going on here, actually kind of like 3. So we're gonna split this up into 3 different pieces and see what we can do for the inverse transform of each of those. So we're gonna have a 7 over s plus 1 squared. We've got a 2s over s plus 1 squared. And we've got a minus e to the negative 2s times 1 over s plus 1 squared. So I'm splitting this up into 3 separate pieces. 7 over s plus 1 quantity squared plus 2s over s plus 1 quantity squared minus e to the negative 2s times 1 over s plus 1 quantity squared. All right. I can find inverse transforms of these, but I've got a problem with the second one. In the second one, I've got an s plus 1 in the denominator, so that means I also have to have an s plus 1 in the numerator. They have to match, right? Remember, when you've got an s minus k or an s minus a, they have to match. So I need to do an s plus 1 in the numerator. They have to match. And I totally just changed my fraction by adding 2. So I also have to subtract 2 back off. I need to subtract 2 back off in order to fix my fraction. So we're going to do 4 pieces and then we'll go back to 3. 7 over s plus 1 squared plus 2s plus 1 over s plus 1 squared minus 2 over s plus 1 squared plus e to the negative 2s 1 over s plus 1 squared. So we're going to split into 4 pieces, but we can combine piece number 1 and piece number 3. So we're going to split into 4 pieces. 7 over s plus 1 squared, 2 times s plus 1 over s plus 1 squared minus 2 over s plus 1 squared, and then that last part with e. So I can combine pieces number 1 and 3, and that will give me a 5 on the top. Question, should it be plus e or minus e? It should be minus e, thank you. Minus e, not plus e. So minus e to the negative 2s times 1 over s plus 1 squared. Minus e, thank you. Okay, sorry, I'm gonna do a new whiteboard. We can also do some canceling in the second part, right? We've got an s plus 1 in the top and an s plus 1 squared in the bottom, so we can cancel one of those s plus 1s. Okay, new whiteboard, here we go. So capital X of s is 5 over s plus 1 squared, if I combine both those first 2 pieces, plus 2 over s plus 1, if I cancel, and then minus e to the negative 2s times 1 over s plus 1 squared. Okay, first one, you should be able to find an inverse transform of, and second one, you should be able to find an inverse transform of. So do the first 2, and then we'll do the third one together. Front of your book, please go ahead and find an inverse transform of the first 2. First 2 inverse transforms there. First one is the second column, second row down, second column, second row down for the first one. And n is equal to 1. So we're going to get 5t e to the negative t for that first one. 5t e to the negative t. People are nodding at me. We like that one. 5t e to the negative t. Second one is the top entry in the second column. So 2 e to the negative t, top entry in the second column, and I have a 2 out in front, 2 e to the negative t. Okay. Third one has that e out in front. So 2 things. We need to deal with the part inside. We'll say that capital F of s is 1 over s plus 1 squared. That's the part inside without the e. So little f of t is t e to the negative t. Again, second column, second one down. F of t is t e to the negative t. And then I've got this e to the negative 2s. So a is equal to 2, right? A is equal to 2 because I got this e to the negative 2s. So what I need is u of t minus 2 times little f of t minus 2. From this e to the negative 2s out in front. U of t minus 2 times f of t minus 2. And so that gives me u of t minus 2, t minus 2, e to the negative times t minus 2. And you can distribute that negative in the top in the exponent if you want to. You don't have to, but you can. Okay, so final answer, we need to subtract that last part. So here's my final answer. Little x of t, 5t e to the negative t plus 2e to the negative t minus u of t minus 2 times t minus 2 e to the negative t minus 2. So I got to subtract that third part. And again, let's take just a second to talk about why this makes sense. If we go back to our initial differential equation, x double prime plus 2x prime plus x equals delta of t minus delta sub 2 of t. And we had that x naught was 2 and x naught prime was 2. So remember what happened with this differential equation. We gave the object a shove at time t equals 0, and then we gave the object another shove at time t equals 2, right? This third part of your solution, and remember the solution describes the motion of the object, doesn't kick in until time t equals 2. That makes sense because at time t equals 2, we gave the object another shove and changed its motion. Here's how we changed the motion of the object with the second shove at time t equals 2. So that's why we've got, here's the motion of the object with the first shove, and then here's how that motion changed when we shoved it again at time t equals 2. We've got kind of two pieces to our solution that gives us the motion of the object. Okay, I am gonna stop sharing my screen so I can see all of you. Questions? Give me a thumbs up. How are we doing at this point in time? Doing okay? I like this lesson because it pulls a lot of stuff back together as evidenced by the homework question at the very beginning of class. So today is definitely a good review because it's pulling a bunch of old stuff back together. Questions? Bethany, yes.
If you were to think about graphing the delta function, would it just be like a single spike at A, basically?
Yes. So if we graphed the delta function, let me show you what that looks like. It would be, it's instantaneous. And so if you have t equals A, we would have a dot right up here. We would have a hole at A, and it would be 0 going out in either direction. So that's what your graph of the delta function would look like. This would be delta sub A of t. Yes. Does that answer your question?
Yes.
Perfect. Okay. Other questions on the stuff that we did today? Other things? Are you understanding why this is a good review also? Yes, it helps to pull stuff back together when you've got some inverse transforms that you need to figure out. Yes. Okay. Tomorrow, we've got a couple more examples because I want to have you play with these in breakout rooms for sure. So I've got at least one example that I'm going to have you guys play with. And then we will talk about something called Duhamel's principle. So that's the last thing in this chapter. Last call. Anything else? And we can do these tomorrow again, but anything else for procedural questions, especially for the test on Friday. I want to make you as comfortable as you can going into this, since clearly this is not ideal. But anything else? Going once, going twice? Okay, I'll email out homework after this. I'll get the recording posted, and I will see you guys tomorrow. Thank you. Have a good day. Bye.